heat today's topic. So first we'll see what is air conditioning system. So our 3 to 4 classes will be like uh, definitions only. So these definitions are very important to understand the concept of HVAC. So when you understand these definitions, so the concept of HVAC will be very easy. Okay, so understand this. So our three classes will be only the definitions. Okay. So first one, what is air conditioning system? An HVAC system is simply a group of components working together to move heat to where it is wanted or remove heat from where it is not wanted. That is the condition space, and put it where it is unobjectionable. Okay, so what a HVAC system is a group of components. So what is a group of components? Group of components means if you take an example of split AC, so you just take the example of the split AC. So here, what we are seeing, there is an indoor unit. So remember this term, indoor unit and outdoor unit. So if generally everyone knows the split AC, right? High wall unit we generally call this as, we can call this also the split AC. So this is our indoor unit, whatever the unit we are keeping inside our building, our room. So inside unit is called as indoor unit, and we will hang one more unit on the outside of the building. So this is the bottom one. This is the outdoor unit. The unit which we are hanging outside of the building, we call it as outdoor unit. Okay, so these two, consider these two, and also the remote and everything like copper piping will be there. So we will connect indoor and outdoor unit with the help of copper piping. Okay, so this all group of components will work together. So everything will work together to do what? To move the heat inside the room. So in the room we will have some heat. So if the temperature inside the room is 35 degrees, 36 degrees something, so we want to decrease this to 25 degrees. So this group of components will work together to move the heat, to remove the heat inside the conditioned space. Okay, and also or remove heat from where it is not wanted. So heat, for example, here in the room, if we don't require the temperature, so what we'll do, we will remove heat from where it is not wanted, the condition space. Okay, so removing heat means whenever we are sending some cool air with the help of this indoor unit, when we are sending some fresh air inside the room, so the heat will be removed and the temperature will goes down to our comfort temperature, that is 24 degrees centigrade. So that is what here we have mentioned, remove heat from where it is not wanted and put it where it is unobjectionable. So if you take some ventilation systems and everything, so we don't require any air. So when there the air will not be used there, so we will exhaust air, the toilet and kitchen air, so to atmosphere, and we'll take some fresh air. So we have the heat air or the contaminated air, so we will take it and put it on the outside, so that we call it as unobjectionable outside air. So simply if we can say that, hey, HVAC is a group of components that will be indoor, outdoor, everything will work together to remove the heat inside the room and to maintain the proper temperature. So that we call it as a air conditioning definition. So next one is heating, the process of adding thermal energy to the conditioned space for the purpose of raising or maintaining the temperature of the space. So what is the heating process? So for example, you there is one room. Okay, I will draw one image here. Sorry. So consider this as one room. So in this uh, we have the temperature of 15 degrees centigrade. Okay, 15 degree centigrade we have in this room. Okay, so what we have to do, what if you remember, what is the comfort, human comfort temperature? So that is 24 degrees centigrade. So here what is required? It is already less than the less than the human comfort temperature. So here what we have to do, we need to add some heat. So then only we will get the temperature of 24 degrees centigrade. So what we will do here, with the help of air conditioning equipment, we will add some thermal energy, that is to the conditioned space. So what is conditioned space? So the space which we are cooling, which we are giving the air conditioning system, that we call it as a conditioned space. So whenever we add some thermal heat by the air conditioning equipment to purpose of raising or maintaining the temperature. So when we add some heat to this room, so it will raise temperature from 15 degrees to 24 degrees centigrade. So the process of adding thermal energy to the conditioned space is called heating process. So heating generally we required for the raising the temperature from lower to the human comfort temperature. Okay, so this is called heating. And next is cooling. So what is cooling? The process of removing thermal energy from the conditioned space for the purpose of lowering or maintaining the temperature of the heat of the space. So here heating, what we have done, if the temperature of the room is 15, so we are raising it to 24 by doing the heating process. So sending the hot air inside the room. So the cooling is used for the higher temperatures. So let me draw one image. So take this as a room. So consider this as a office space or bedroom or whatever. So we have the temperature of 35 degrees centigrade. So here what we required, here we have to lower the temperature to the 25 degree, 24 degrees centigrades. Okay, 24 degrees centigrade. See here what we are going to do, we are adding some cool air inside the room. So the process of removing thermal energy, heat from this conditioned space for the purpose of lowering or maintaining the temperature of the space. So removing thermal energy means whenever we send the cool air inside the room, so the heat will be removed and the temperature will be goes down to the required temperature. Okay, so this is called cooling. And next one is humidifying. So we'll see what is humidifying. So humidifying is the process of adding water vapor to the air in the conditioned space for the purpose of raising or maintaining the moisture content of the air. So humidifying. So for example, I will draw one triangle here. So we have seen that comfort humidity in our last class. The comfort humidity is for the human, the comfort humidity is 50 to 60%. So for taken a room, so here the temperature is 25 degrees centigrade. So that is a human comfort temperature, 24 degrees centigrade. And so we also need to uh, check the humidity inside the room. So that is generally 50 to 60% for the human comfort. So for example, if I have 24 degrees centigrade temperature and the humidity is like 30%. Okay. So if the humidity is 30%, so what I need to do? So I need to increase the humidity to 30 to 50%. So that is our human comfort temperature. So to increase this from 30 degrees to 30% to 50%, so I have to do the humidifying process. Okay. So the when the temperature is 24 also, if the humidity is not 50 to 60%, so the people inside the room will not be feel comfort. So best example is our like when you take the cooler. So we generally use the cooler inside our room homes. So we will place the cooler inside the room, and when we are using that, so after some time, so we will not feel comfort. So why? Because there uh, the cooler is using some water. So due to that water will evaporate and mix up with the air inside the room. So due to this, the humidity will go high. So humidity will be of 80%, 70, 80, and 90% also it will be there. So when there is that much of high or low humidities, so we will not feel comfort. So that is the reason when we are using the cooler inside our room, so we will not feel that much comfort after 1 hour or 2 hours. So if we place outside, so then that water will be evaporated to outside, so we will get some comfort. So that is the best example, and also the mm, people who are living in the like oceans, nearby oceans, so there also the water evaporation will be more. So the humidity also more there. So if the humidity is more, so we'll get sweating, like we'll not feel comfortable. Okay, so here we have 30% of humidity. So what we have to do? We have to do humidifying. So what is humidifying? The process of adding water vapor to the air in the conditioned space. So when we add some water vapor, so water vapor we know that, and so when we heat, we will get the water vapor. So vapor form, so that you can see the image over here. So the instrument is providing some vapor in the form of the water in the form of vapor. So that this is called a humidifier. So this humidifier will add the water vapor. Due to this, the percentage of humidity will raise from 30% to 50%. Okay, so this is called humidity. So humidity also necessary for the so in general areas like office spaces, residential, everywhere, so people generally not use. So if you go to pharmaceutical or food manufacturing areas and the operation theaters, hospitals, so they will prefer certain humidity. So there this is necessity to maintain the humidity. Okay. So next one is dehumidifying. So the process of removing water vapor from the air in the conditioned space for the purpose of lowering or maintaining the moisture content of the air. So we have seen the humidifying. So what is dehumidifying? So for example, so I will draw one room here. So consider this as a room, and take if we have the temperature of same 25 degrees centigrade, but the humidity here is, instead of for human comfort is 50, so here we have 85% humidity. So the humidity is high, more than the required humidity. So so here what we need to do, so we need to reduce the humidity from 85% to 50%. So the process of removing water vapor from the air in the conditioned space for the purpose of lowering or maintaining the moisture content of the air. So we need to remove the moisture from the air. So whenever we remove the moisture from the air, so what how much, if the moisture is more inside the air, so the humidity is high. So see, you can easily remember that if the moisture content is high in the air, so we will get high humidity. So if moisture is less in the air, so we'll get less humidity. So whenever we are getting high humidity, so 85 is high, so obviously the moisture content is high. So we need to remove this. So removing of the moisture from the conditioned space and maintaining the required humidity is known as dehumidifying. Okay. So here we need to reduce it to 85 to 50%. So that is dehumidifying. So dehumidifying generally we will use duct heaters or hot water coils also we will use. So you can see the image. So this is called duct heater. So we will place it in the duct. So we'll see what is the duct in the upcoming classes. So we'll place it in the duct to maintain the required humidities. Okay. So next one is cleaning. So what is cleaning? So cleaning the process of removing particles, dust, etc., and biological contaminants, insects, pollen, etc., from the air delivered to the conditioned space for the purpose of improving or maintaining the air quality. So we have discussed that. So every room requires some outside fresh air. So that is of 10%, or it is more than that or less than that based on the our heat load calculation. So when we are taking the fresh air from the fresh air, nothing but outside air with filtered air. So outside air when we are filtering and taking inside, so we call that as a fresh air. So remember this term for the next all classes. So when we are taking when we are taking the outside air, so without filtering, so you can see the right side bottom image, so the room will be contaminated like this. So that's why the cleaning process is definitely required for outside air. So outside there will be like continuous generation of the smoke, dust particles, everything from the vehicles, roads, so that will be polluted air. So before taking that, we need to filter it. So the process of removing dust. So we need to remove dust and biological contaminants like insects, pollens, etc. from the air delivered to the soil. So all these terms we need to filter and we need to take the air inside the room. So that is the cleaning process. So the air always it should be filtered. So next, ventilating. The process of exchanging air between the outdoors and the conditioned space for the purpose of diluting the gaseous contaminants in the air and improving or maintaining air quality, compositions, and freshness. Ventilation can be achieved either through natural ventilation or mechanical ventilation. So, okay. So, what is ventilation? Ventilation means the simply the process of exchanging air between the outdoors. So we have discussed in the last class also. Ventilations we have exhaust systems and fresh air system. So exhaust system means removing the air from the room and throwing it to atmosphere. Fresh air means taking the outside air and filtering and sending into the conditioned space. Okay. So the ventilation is the process of exchanging the air. It is the just the process of exchanging the air between outdoors and the condition. Exchanging means we are removing the inside air and throwing outside, and we are taking fresh air and to the conditioned space. So, what is the purpose of this? For diluting the gaseous contaminants in the air. So, maybe any gaseous contaminants, and also the improving of air quality. So air quality should be increased. So whenever we are recirculating the air inside the room continuously, so we'll not feel comfort. So and the comfortness and composition and freshness. So are also used for freshness. Ventilation can be achieved either through natural ventilation or mechanical ventilation. So we have discussed that ventilation system is used for toilet exhaust system and the basement ventilation system, car parking ventilation system, and the kitchen ventilation system. So for these three, so we have the natural method and also a mechanical method. So natural method means, so if whenever the rooms have the ventilation properly, so if you are there is a kitchen in the restaurant, so the kitchen is of open type or it has multiple openings like windows, so many windows, so doors, everything. So the air is properly circulating inside the room from the outside atmosphere. So then there is no requirement of doing the exhausting and taking fresh air. So already we have the openings present in the kitchen. So due to this, the air is circulating from outside to inside. So there is no requirement of doing it any mechanical ventilation. So mechanical ventilation means like we are using some uh, fans like centrifugal fans, inline fans, and extracting the air from the kitchen and throwing it to atmosphere. So when there is no proper ventilation, so not only for the kitchen, if the toilets has also proper ventilation if we have, so we don't need to go for any mechanical ventilation. Like we don't need to use any fans to exhaust our fresh. Okay. So similarly, like this, we have car parking ventilation. Car parking also we have if we are doing it for the ground floor. So if the ground floor we have the open walls throughout the entire boundary. So we don't need to do any ventilation system there. So generally the car parking will be of basements underground. So there is no proper ventilation. So there we need to do it. So this is the ventilation system. Next one is heat. What is heat? According to second law of thermodynamics, heat is transferred from higher body to lower body temperature. So standard unit of heat in the international system of SI unit is the calories and BTU. So heat transferred through conduction, convection, and radiation. So different forms of heat are sensible and latent heat. So as per the second law of thermodynamics, heat is transferred from higher body temperature to lower body temperature. So for example, to take one, so take consider this as some vessel or something. So this is heated to certain. We have cooked some food or something in this vessel. So we have kept aside, and this is a empty vessel or uh, like it is also we have something. So when we attach these two, so what will happen? Heat will transfer from this body to this vessel to this vessel. So for example, this vessel we consider this as a high temperature body. So why? Because this was in this vessel we have cooked some food. So the vessel has some temperature that is of high temperature. So this is an empty vessel. So we have already kept aside. So when we attach these two, so what will happen? This will become high temperature body and this will become low temperature body. So as per second law of thermodynamics, heat is transferred from higher body means this body to this body. So this is lower body. So that is called heat. So heat we have the units that is in SI it is called calories and BTU. So heat is transferred through three forms: conduction, uh, convection, and radiation. So this we will see it in our next class. And different forms of heat. These are forms. How many forms the heat will be? That is of sensible and latent heat. These are two forms. So these all definitions: conduction, convection, radiation, and sensible and latent heat. We will go and discuss in our next class. Okay. Okay. So first one is sensible heat. So what is sensible heat we will see. So these listen these topics well because these sensible heat, latent heat, and conduction, convection, radiation. So these definitions will be used like this topic will be used in heat load calculation. So while we are calculating the heat load, so these forms of heat we will use it and we will calculate the load. Okay. So these are the most important definitions. So first one is sensible heat. Sensible heat is the amount of energy released or absorbed by a chemical substance during a change of temperature. Okay. Simply sensible heat is the amount of energy released or absorbed by a chemical substance during a change of temperature. So this for best example for this is you can see the image here. So the uh, glass or a vessel which has the water of temperature 15.6 degrees centigrade. Okay. And when you heated, so the temperature has reached 100 degrees centigrade. But if you see sensible heat, there is only change in temperature, but not the physical quantities. So physical quantity here that we see water. So water remains same here when you heat it, but the temperature will vary. So that we call it as a sensible heat. Okay. So there is no change in physical quantity or uh, so the quantity remains same, the water remains same, only the temperature will be changed. So that is called as sensible heat. Okay. So next one is a latent heat. The same example what we have taken from the sensible heat. So same one here we have taken. So the quantity of heat absorbed or released by a substance undergoing a change of state, such as ice changing to water or water to steam at constant temperature and pressure, also called heat of transformation. Okay, so here in this vessel we have the water. The temperature of that water is 100 degrees centigrade. Okay, so we know that the boiling point of water is 100 degrees centigrade. Okay, so when water temperature reaches the boiling point, so that is 100 degrees centigrade, what will happen? The water will start evaporating. So whenever you are boiling some water on the stove, so after certain time, the water reaches certain temperature, so what will happen? The water will start evaporating. So the point where the water starts evaporating, that we call it as a 100 degree centigrade. So here we have the 100 degree centigrade water. So if we are heating still, so what will happen? Uh, the water will start evaporating. So here what happens? So the temperature it reaches 100. So there is a constant temperature. So if you see here we have 100 degrees centigrade and here also we have 100 degrees centigrade. But the physical state the state is changing. The state is changing from water to moisture. So when it is evaporating, water will become like a moisture. So this is the latent heat and sensible heat. If in sensible heat, so the temperature will vary, but the physical state will be constant. So water will become water only the temperature will be changed. Next in latent heat, so the water will change its states and it will start evaporating, but the temperature will remain same. There is a constant temperature and pressure. For latent heat, you can see uh, the quantity of heat absorbed or released by a substance undergoing change of state, such as so these are the best examples. Ice changing to water. So when you keep the ice, take it out from the refrigerator and kept it out, so the ice will convert to water. So that is also one example. Water to steam. Okay. So these are the best examples for the latent heat. Okay. So next one is modes of heat transfer. Okay. These are three modes of heat transfer. First one is convection, conduction, and radiation. Okay. So first we will see the conduction. So conduction is the transfer of heat or electric current from one substance to another by direct contact. Okay. So here in image you can see we have the fire. On top of it we have taken one vessel with the water. Okay. So we are heating that vessel. So, okay. So by this example we'll get the three modes of heat transfer uh, examples in this one image. Okay, so we'll see the conduction first. The transfer of heat or electric current from one substance to another substance by direct contact. So if you see here, this is the vessel which has the water on this vessel, and it is continuously heating by the fire. So when it's heated, so the first the vessel will gets heated. So when we heated the vessel, so if after reaching the certain temperature, so the uh, vessel has the direct contact with this handle. So the gripper or handle we can say. So it has the direct contact with this vessel. So in conduction mode of heat transfer, it will transfer the heat from one substance to another substance by direct contact. So if there is any object, so if it has the direct contact, so the heat will transfer from one body to another body. So this is the one body to another body. So that is called conduction heat transfer. So this vessel will get heated, and this heat will transfer to the handle which is attached to this vessel. So that is called conduction. Okay. So I will read the definition one more time. The transfer of heat or electrical current from one substance to another by direct contact. So we have the direct contact. So the heat is transferring from one object to another object. Okay. So that is conduction. The next one is convection. Convection, the transfer of heat through a fluid, liquid or gas catched by molecular motion. Okay. So this convection. So same example when you heated the vessel. So in this, the transfer of heat through a fluid or liquid or gas. So not by any substance. Here, the transfer of heat that will be from the liquid or the gases. Okay. So we have the liquid in this example, that is the water. Okay. So uh, when you heated the vessel, so first what will happen? The bottom level of water will be heated. Okay. So whenever the vessel is heated, firstly the bottom water will be heated. So these bottom water, these molecules will heated and it will goes to top. So you can see the arrow directions. So when the heated molecules that heated, so that will goes to the top of the water, and the cool water which is on the top side, that will comes to the bottom. So you can see the down arrows here. So this is the cyclic process. So the heat is transferred from one molecule to another molecule by causing the molecular motion. So when this molecular moves from top to bottom, so that is a cyclic process. Uh, this cyclic process will helps in transfer of heat. Okay, so that is how the convection mode of heat transfer will be. Okay, so simply convection mode of heat transfer is caused by a molecular motions. This is a water molecules. So water molecules will move from top to bottom, from bottom to top, and it will transfer the heat. Okay. So next one is radiation. Radiation energy that is radiated or transmitted in the form of rays or waves or particles. Okay. So you can see the image here. So when we are heating uh, this vessel, so obviously there will be a transfer of rays. So whenever if we go near to any fire, so we'll get the heat. So that is a form of waves And also other example is uh, we will get the heat from the sun in the form of rays. So that is also one kind of radiation. Okay. So it in simply that is transferred in the rays or waves, not in direct contact or not in the liquid or gas. So it will be sent in the form of rays or waves. Okay. So we'll get the heat from the sun. That is the best example. You can always remember that. So that is the radiation here. Okay. So these are the three modes of heat transfer. So next one is hotness. What is hotness? We know that adding of heat. So if we required in winter season, if we have low temperature nothing but the 15 degrees centigrades, 12, 18 degrees centigrades. So we'll do some heating and we'll add some heat inside the room so that we will get the human comfort temperature that is 24 degree centigrade. So next one is coldness. Coldness is removing of heat. So coldness, uh, yes, in coldness. So for example, if we have high temperatures inside the room, so that 35 degrees, 38 degrees. So what will happen? We will add some cooling inside the room. So to remove the heat in the room. So that we call it as coldness. Okay. So next one is temperature. So the degree of hotness or coldness which can be measured by ordinary thermometer is known as temperature. So whatever it may be. So when we want to measure the temperature, so what we'll use the thermometer. So if we go to any hospital also, they will use thermometers to measure the temperature. Okay, so that may be of hotness or coldness. So in this our HVAC, we will use to measure the temperature of the room. So how much temperature is there? What is the hotness? What is the coldness? So when we know the temperature, so not only the room, outside environment temperatures also will differ from country to country, state to state. So uh, that we measured by the ordinary thermometers. So the temperature scales normally employed for measurement purpose are the Fahrenheit and Celsius scales. So the temperature is measured in two scales. One is Fahrenheit and one is Celsius. Okay, so this how to convert this centigrade to Fahrenheit and Fahrenheit to centigrade. We will see it in next slide. So we generally measure it in Fahrenheit and also in centigrade. So here also, if you see in the latent heat and the sensible heat, we have two units here. One is 60 degree Fahrenheit and 15.6 degrees centigrade. So these two are same. Here also 212 degree Fahrenheit and 100 degree centigrades. So this is just a conversion. So we'll see what is humidity. So we have seen in last class. So simply if we say the amount of moisture present in air. So when we measure the humidity, so the amount of moisture present in the air. So nothing but our surrounding air, anything we can measure. So that is humidity and humidification, adding of moisture. Okay. So humidification, when the humidity is low, so if it is 30%, so we'll add some moisture to increase the humidity. So dehumidification, so we have the high humidity 80%, 90%, we will remove the humidity and that is called as dehumidification. Okay, next is evaporation. So evaporation, it is the process of change of phase from liquid to vapor by heating is known as evaporation. So when we heated the water. So that is a good example. When we heated the water, so when it reaches its boiling point, 100 degrees centigrade, what will happen? It will start converting to vapor, liquid to vapor. So that is called evaporation. So here we have seen in latent heat. So the temperature is 100 degrees centigrade. So you can see it started evaporating. That we call it as a evaporation. Okay. So condensation. So this is also a most important topic, uh, definition. So it is the process of change of phase from vapor to liquid by cooling is known as condensation. So when we cool any substance, so that vapor will for example take the normal air only. So take the normal air. So when you cool it to certain temperature, so the normal outside temperature, let us consider it is 35 degrees centigrade. So you have to cool a room, one room. So you have taken the outside air that is of 35 degrees centigrade, and you cool that air to 18 degrees centigrade or 15 degrees centigrade. Okay. So what will happen at a certain point when you started decreasing the temperature from 35 to 18 or 15? So there is one uh, point, like take it will differ from area to area. So let us take it as say 18 degrees centigrade. When you lowering the temperature from 35 to going on till decreasing, so you cannot decrease the temperature whatever you like, 8 degrees, 5 degrees, you cannot do that. So when the air reaches certain temperature, that for example 18 degrees centigrade or 15 degrees centigrade, so it will start converting to liquid. Okay. So the best example is, if anyone is using the split ACs inside the room in their homes, so there will be a pipe which is connected to the split AC. So the in that pipe we will get some droplets of water. So that will uh, fix it to outside, or there will kept some provision for collect the water. So that is called the condensation. So there also, if the air reaches some certain point of temperature, so it will start condensating. It is nothing but, so here there is a vapor in the air, so that vapor will convert into liquid by cooling is known as condensation. Okay. So that is a condensation process. So next one is boiling temperature. So temperature at which evaporation starts. So we have discussed that the boiling point of the water is 100 degrees centigrade. So when this boiling point reaches, so it will start evaporating. So every liquid or gas, everything has a boiling point at which it will start evaporating. So dew point temperature. Okay. So nothing but the condensation, that will be same. We can call it as dew point temperature also. The temperature at which condensation starts. Okay. The condensation, we know how it will convert the vapor to liquid. So that we call it as condensation. When we lower the temperature, when we decrease the temperature, so it will start converting from vapor to liquid. So that is called condensation. The at that point, what the temperature uh, we know we'll measure. So that temperature we call it as a dew point temperature. So we have discussed that certain temperature we have taken 18 degrees centigrade. So here also the dew point temperature, if you consider that as 18, so that called as a dew point temperature. So simply the when you measure the temperature at the condensation process, that is called dew point temperature. Okay. So pressure is defined as a force per unit area. So how much force is required per unit area, we can say it as a pressure. Next one is British thermal unit. So this is also most important. So we use this term in the heat load calculation. So understand this better. BTU is the amount of heat required to raise the temperature of 1 pound of liquid water by 1 degree Fahrenheit and at a constant pressure of 1 atmosphere. So how much amount of in BTU means how much amount of heat is required so to raise the temperature of 1 pound of liquid. So if we say generally, so we will measure the heat in the form of British thermal units, so BTU. So if you take how much heat is coming inside the room, so heat will transferred from the windows, slab, walls, from the outside environment to inside environment. So the amount of heat is transferring from outside environment to inside environment, we consider that as a BTU, that is British thermal unit. Okay. So this we will calculate in the heat load calculation. So there you will understand it better. Next is ton of refrigeration. So it is a unit of power used to describe the heat extraction capacity of refrigeration and air conditioning equipment. So in every unit, so if you have purchased any split ACs for the home, okay, so you might know this term tonnage of refrigeration. So if you go to the any uh, electric or electronic shop, so for purchasing the ACs, so they generally ask how many tons AC is required, or else they will ask the area of the room, and I will take the tonnage. So whenever you are purchasing anything, any air conditioning equipment, so that refrigeration equipment will be described in the form of tons. So 1 ton, 2 ton, 3 tons. So these tons, how these we will get it in the heat load calculation. So outside they generally use the thumb rule and they will show the give the units, but in our case we need to calculate the heat load and we will get the exact tonnage. Okay, so it was originally defined as the rate of heat transfer that results in the freezing or melting of 1 short ton of pure ice at 0 degree centigrade in 24 hours. So if we melt a pure ice at 0 degree centigrade in 24 hours, so what is the rate of heat transfer results in freezing or melting, that we measured it as a ton of refrigeration. Okay. So it is quite difficult to understand this, but just remember that unit of power used to describe the air conditioning equipment. Okay, so that is sufficient to understand this. Okay, so that is ton of refrigeration. So remember this ton of refrigeration, we also write it as a TR. So from next on upcoming classes or anywhere, so that we are going to use it as a TR, tonnage of refrigeration. Okay. Next one is saturated air. So 100% of moisture present in air. So whenever the moisture content is present in the air is 100%, so we call that air as a saturated air. Okay. So we have discussed that humidifying, dehumidifying. So whenever the temperature reaches 100, the humidity reached 100% in the environment, so that air we can say it as a saturated air. Okay. So next one is unsaturated air, partially moisture present in the air. So partially means that may be 80%, 70, 60%, but not the 100%. That air we call it as a unsaturated air. Okay. Next one is velocity. Velocity is known as rate of change of displacement. Okay. So the velocity So we have separate some velocity so that it will change the displacement. How much rate it is changing the displacement, we measured in the form of meter per second and FPM. So this velocity we will generally used uh, in the duct fitting. So when we send the required air from the ducts, so that we will send it with the help of certain velocity. So that will be a 1500 FPM or 2000 FPM. So that depends on the application. So any of that we'll go to discuss in the ducting topic. Okay. So these are the certain abbreviations. So you need to keep it in mind always. So hereafter we generally call these abbreviations in the short form. So you no need to confuse in the upcoming classes. So thoroughly go through these abbreviations. So first one is CFM, cubic feet per minute. Okay, CFM nothing but the cubic feet per minute, and so that generally the air. So when you are uh, calculating the heat load, we will get this CFM, how much air is required inside the room in a 1 cubic feet per minute. So cubic feet we know that length, width into height of 1 feet, 1 feet and 1 feet height, width, length and height. So how much air is required in that space, we call it as a cubic feet per minute, CFM. And next is CMH, cubic meter per hour. So this is also same thing, but here we are using the units meter instead of feet, CMH. And TR, just now we discussed tonnage of refrigeration. And BTU, British Thermal Unit, the short form is BTU. ACPH, air changes per hour. Okay, so how many times the air has to be changed inside the room in a hour, that is called ACPH. So this will be used in toilet ventilation system and kitchen exhaust systems and staircase pressurization. So with this ACPH will be used, and liter per second. So this also used for the like it is the other form of CFM to measured in, if we are using inches, so we need to measure it in LPS, liter per second, and MPS, meter per second is velocity, and FPS is feet per second. To measure the velocity, we will use this two terms, MPS and FPS. So next one is temperature conversion. So you can see these conversions from one unit to another unit. So temperature, when you want to convert from centigrade to Fahrenheit, the formula here it is 9 by 5 into centigrade. So if it is 15 degrees centigrade, you can enter 15 there plus 32. So you will get the required temperature in the form of Fahrenheit. So same, if you have the value in Fahrenheit, so you want to convert it to centigrade. So 5 by 9 multiplied by Fahrenheit F, that is 25 something anything, minus 32. We will get the temperature in centigrade. So this also very most important, these temperature conversions. Okay. Next is ton of refrigeration. So this is also most important conversions that always you need to remember. 1 ton equal to 12,000 BTU per hour. So if you convert from ton to BTU, it is 12,000, 1 ton, that is 12,000 BTU per hour. Okay. And this one we will use it in heat load calculation. So always remember this term, 1 ton equal to 12,000 BTU per hour. And next one is 1 ton equal to 3.516 kilowatt, can also convert to kilowatt. And next one is 1 ton equal to 3025.9 kilocalories per hour. Okay. Next 1 ton equal to 200 BTU per minute. This is hour and this is minute. Next 1 kilowatt equal to 3412 BTU per hour. Okay. Heat 1 watt equal to 3.41 BTU per hour. So these all are conversions. So The most important one is 1 ton equal to 12,000 BTU per hour and 1 ton equal to 3.516 kilowatts. So at least you just remember these two terms. Next, that is related to tons, and here we have flow of air. 1 LPS equal to 0.119 CFM. So I think the call will get disconnected. So please rejoin. I will disconnect the call and we'll continue. Okay. The CFM, we also have some more other units. So the air will be measured in. So 1 liter per second equal to 2.119 CFM and 1 CFM equal to 1.7 CMH. So CFM, nothing but the air. So that if we measured in liter per second, it is measured in CMH, cubic meter per hour, cubic meter per second, cubic meter per second to CFM, cubic meter per second to LPS. So these all is a flow of air conversions. Okay. So the most important thing that you need to remember here, that is 1 liter per second here equal to 2.119 CFM, and also the CMH 1 CFM equal to 1.7 CMH. Okay, so these two terms are most important. You need to remember this. Okay, so CFM full form is cubic feet per minute. CMH equal to meter per hour. Okay, LPS equal to liter per second, and CMS is cubic meter per second. Okay, so don't get confused. So pause the video and note down these most important units. Okay, so maintain the notes. So whatever these like important topics will be there, so wrote it everywhere. Okay, and velocity of water, 1 fps equal to zero point 0.3 meter per second. So 1 feet per second equal to 0.3 meter per second. fps equal to feet per second. So that is related to flow of air and velocity of water. So this velocity of water, we will use it in chilled water system. So remember this thing also. So next one is distance. So we all know that the some distance measurements, we know that that is, so if we don't know, so we can go through these measurements. So 1 meter equal to 1000 millimeters, and 1 meter equal to 100 centimeters, 1 meter equal to 3.28 feet, and 1 meter equal to 39 inches. So 1 feet equal to 12 inches, 1 inch equal to 2.54 centimeters, 1 inch equal to 25.4 millimeters, and 1 centimeter equal to 10 millimeters. And area, if you want to convert from square meter to square feet, so that is 1 square meter equal to 10.76 square feet. So if you want to convert it reversely from square feet to square meter, so divided by 10.76, you will get it in square meters. So here in distance, so everything is important. So these all are very basic unit conversions. So you might know this, but you always need to remember in your mind. So that will be easy. So for when you go for any site for measuring the site dimensions or for site visit, so you need to keep these units on your mind so that you can convert it easily. So for example, you are measuring in meters, so the client always, though they don't remember all the units, so he will ask you to say in the square feet or feet. So if you know this all units, so immediately you can convert and you can see this. Okay, so there that will be used uh, mostly. Okay, so these are the topics for today. So till here, if anyone has doubts, you can ask me.